We are continuing lecture 5, sorry. We are continuing lecture 5. If you look at here now, you will see that the beam here is loaded differently. It's loaded triangularly. It's loaded, the load is triangular in shape. Unlike the other load that was a UDL. UDL is a rectangular loading. It's a rectangular loading. And to get the total load, like I told you earlier, the span multiplied by the intensity of the load will give you the total load, which is the area of a rectangle. In this case, to get the total load here is just the area of the triangle. To get if to say it was loaded with trapezoidally as a trapezium, just to get the total load is the area of the trapezium. Even if it's loaded parabolically. So here it is loaded triangularly. So to get the total load is just the area of the triangle will give you the total load. So to start, now we want to get reactions. So total MR B is equal to 0, so that we can get reaction A. So if we do that, we have 6 RA, make RA a moment. Turning this way, the load turns against it. So to get the load now, to get the load itself and make it a moment, I then minus the area of the load is 6 times the intensity of the load here is 4. Look at it, it's 4. So times 4 over 2, the area of a triangle. The area of the triangle. Then to make it a moment, the distance from the center of gravity of the triangle to the end, to the fulcrum, that is point B to the fulcrum. That's the distance from the center of gravity of the triangle. And the center of gravity of the triangle from the larger end is 1/3 of the length, while from the other tip is 2/3. So in this case, we are moving from here to the larger end, so it will be 1/3, which in this case is 6 over 3. 6 times divided by 3. So that is the load. This is the area of the load times the distance from the center of gravity of the load. To make the load a moment, this is equal to 0 because there's no other load there at the end. So RA then is equal to, even if I cancel this, I have 12 minus 12 times, that's so sorry, because it changes sign, it becomes 12. 12 times 6 divided by 3, that is 2 over 6, which is equal to 4 kilonewton. That is reaction A. So we need to get reaction B. I have total moment about support A equal to 0. I start. I have 6 RB this time around. 6 RB. The load is against it. So minus the load, the load, which is the area of the load, which is 6 times 4 over 2, area of a triangle. Then distance, because before we were taking moment at point B, now point A. I told you the distance from the center of gravity to the tip is 2/3. So times 2 times 6 over 3. So it's equal to 0. There's no other load. That means, or another moment. RA cannot give moment at this own point. RB is equal to, just like we did before, this is 12. This 12 times 4 over 6, which is equal to 8 kilonewton. That is reaction B. We have gotten the two reactions. Get the total load is the area of the triangle. Since the load is triangularly shaped, the structure is loaded triangularly. So the shape of a triangle. So since we have gotten the reaction now, is to calculate the bending moment. The bending, as usual, because of the type of support, the bending moment at A. The moment at A is equal to 0. The moment at A is equal to 0. Since M at A is equal to 0, we now move. Let's get at the middle. And I take moment. So I have M at the middle. Looking at where I started, I say it's positive. Then reaction A is against it, minus reaction A, which is 4 times 3, because at the middle is where I'm taking a moment. Then the load plus the moment of the load. For me to get this load, because from A to the point to the middle here, I need to get this ordinate of the load. I need to get this ordinate. And to get it, I use similar triangle, because this is C and D. Triangle A. Okay, let's say this is E. AEB is similar to triangle ACD. Triangle AEB is similar to the triangle ACD. And one characteristic of similar triangle is the equality of the ratio of sides. Equality of the ratio of sides. If that becomes the case, I have that here, this length, ratio of sides, 6 over 4, because this is known, 6 over 4. Equality of the ratio of sides is equal to 3 over, let me call it, over CD. Which means, if I cross multiply, I have that CD is equal to 3 times 4 over 6, which is equal to 2. So the intensity here is 2. So that means I can now get the area of this triangle, which is in this case 3 times 2 over 2. 3 times 2 over 2, which is the area of the triangle. Then times the distance from the center of gravity of this small triangle to the D where I'm taking the moment, times the area of the from this length to this length, which in this case it is 1/3. 1/3 of the length, which is 1/3 of 3, which is equal to, which is 3 over 3, because the total length from A to D is 3. This is equal to 0. So M at the middle is equal to, that's 4 times 3, which is 12. This cancel, that's 1. That's gone. That's minus 3, which is 12 minus 3, which is 9 kilonewton meter. That's the moment at the middle. That is the moment